Hello, my name is Alexa Hurlbert, and in this video I will solve an example problem to explain how to find the Thevenin equivalent of a circuit. The problem I will be solving is problem 41 from chapter 4 of the 4th edition of Fundamentals of Electric Circuits by Charles Alexander and Matthew Sudoku. The first thing we need to do in order to find the Thevenin equivalent is find the Thevenin resistance. In this problem, there are no dependent voltage or current sources. Because of this, we can use a very simple method to solve for R Thevenin. For this method, all we have to do is find the equivalent resistance from A to B. For this problem, the 14 and 16 ohm resistors are only connected at one node, making them in series. We add them together and find their equivalent resistance is connected at two nodes to the 5 ohm resistor, making them in parallel. We add the inverses of these resistors, then take the inverse of that answer to find that R Thevenin is 4 ohms. The second method is more complicated and unnecessary for this circuit, but you need to know it because it's the only method you can use if there are dependent voltage or current sources. For this method, you have to short your voltage sources, which means removing them and replacing them with a wire, and open your current sources, which means removing them and replacing them with open terminals across which no current will flow. You also have to place either a current source or voltage source connecting the A and B terminals. If you choose a current source, you will have to solve the problem using nodal, and if you choose a voltage source, you will have to solve the problem using mesh. I wanted to use nodal, so I chose a current source, and I made it 1 amp to make my life simple. To solve this circuit using nodal, the first thing I need to do is to identify my nodes. We are going to set the bottom node, voltage V, to ground, making it 0. That just leaves two nodes, nodes VA and V1, to solve for. Next, we need to decide which way we think the current is going. It doesn't matter what we choose, just stay consistent and the math will work itself out. For node V1, we have current leaving, so negative V1, heading to VA over 14 ohms. We also have current leaving heading to ground over 6 ohms. Setting this all equal to 0 gives us the following equation. For node VA, we have current arriving, so positive, coming from V1 over 14 ohms. We also have current leaving heading to ground over 5 ohms and 1 amp arriving from the dependent voltage source. Setting this all equal to 0 gives us the following equation. Now that we have two equations, we can solve for two unknowns. The first thing that you want to do is to simplify the fractions. So you multiply by both the denominators. In this case, you multiply both terms by 14 times 16. Then you can combine like terms, put separate terms on opposite sides of the equation, and solve for one of the terms in terms of the other. We do the same process to the second equation and get 70 amps is equal to 19 VA minus 5 V1. We already solved for V1 in terms of VA, so then we can plug that equation into our second equation, leaving us with one equation with one unknown. This allows us to solve for VA. Next we find VAB, which is as simple as subtracting VA from VB. In this case, 4 volts minus 0. Then to find R Thevenin, we divide VAB by the test current we applied earlier. We chose 1 amps because this equation just becomes 4 divided by 1 gives us R Thevenin is equal to 4 ohms, the same result we got from method 1. Finally, we need to find V Thevenin. We can use either nodal or mesh to do this. I'm going to use mesh. We can see by inspection that I1 is equal to 1 amp, and by looking at the bottom node where I2 and I3 meet, that I2 is equal to I3 plus 3 amps. Because of the 3 amp current source, we have to use a super mesh. Doing so gives us the following equation, which simplifies down to 20 I2 plus 5 I3 is equal to 20. We solved for I2 in terms of I3 earlier, so now we can plug that equation into the one we just found. Solving for I3, we find that I3 is equal to negative 1.6 amps. Thevenin is merely the voltage from VA to VB. We set VB to our ground earlier, so we know that that is 0 volts. Now we just need to find VA. Since we know VB is equal to 0 and we know negative I3 flows across the resistor, we know that VA is equal to 0 plus negative I3 times negative 5, the 5 being negative since the current flows through the negative terminal first. And we simplify that to find that VA is equal to negative 8 volts. Since Thevenin is VA minus VB and VB is equal to 0, we know that Thevenin is equal to VA, which is equal to negative 8 volts. So there you have it. For this circuit, R Thevenin is equal to 4 ohms and Thevenin is equal to negative 8 volts. I hope you have found this video helpful.